Hello everyone, so today we'll be trying to do the a cellular automaton, which will be a one-dimensional, like it's saying here, one-dimensional cellular automaton. It's called the elementary cellular automaton, which makes sense, right? It's the elementary one. It's the most basic one. Having said that, we'll be doing it first before saying it's the simplest one, but it's the most elemental since it's a one-dimensional evolution. So the principle is that you have, let's say, a given amount of cells, right, in one dimension, and those cells have two possible states, either 1 or either 0. Um, and you define a rule which would be between 0 and 255, I believe, right? That would make sense. Let me validate, but I believe it is between 0 and 255. It is. So we basically will set a rule between 0 and 255 as a number. We will convert that number to a string, right? And then we will try to and we will convert it. So let's say we take 30. We'll convert it to a string as base 2. So 30 would become 11110, and we need eight possibilities, right? So we'll pad the start with zeros of that string, and then we'll convert it back. Well, I guess we could just split the string. Yeah, I mean, we'll start with this. We might want to keep it as a string, but in any case, this should be the first step, right? So, for example, this is the example that they have on the website. But for example, here, right? So this here is the first, the 0th and the first iteration for the Cellular Automaton. So we'll be trying to do this. So yeah, let me get started, right? So we'll have our rule, not here, but over here, right? So const rule equals, let's do 30 for right now, since we expect the same result as they have on here, which is this, I believe, right? Yeah, that's the one, right? So this is rule 30. And this is what's supposed to give us. So I will also possibly there's a better way to do this, but I will do it like that. I will set I'll set like a scale, maybe 30 for right now as well. We will set an array of cells, right? Cells will be equal to an empty array. Well, yeah, sure. I mean, it's not going to be equal to anything. Or we can set it up so that it's equaling an empty array for the moment, and just do for let I is equal to 0, I is less than the width divided by the scale, I plus plus. Awesome, and we will floor that value, or we could seal it. It doesn't matter actually. All right, so we'll do cells index I should be equal to, let's set all of them to 0 by default, and let's get the center cell, which should be cell index cells dot length divided by 2 equals to 1, right? So all of them will be starting at 0 apart from the middle one, which will be starting at 1. So it should be this specific case, right? So now that we have our cells, right, what else do we want? We want to set the rule set. Maybe want to call it rules. So rules should be equal to the rule, and we want to convert it to a string, right? As base 2. We want to pad the start of the string with pad start is the length, so we want a length of 8 in total, and we want to pad it with zeros. Okay, that's good. And what we'll do now is we will just make it as an array of an array of numbers, right? So we split at every element, and we can map it to be basically parse int a right? I believe this should be, if we console log, and this can be a const. If we were to console log rules, it should be 0, 0, 0, 1, 1, 1, 1, 0, right? So let's see if we do get this. Open up the console. All right, so what do we have here? It's a bit small. Let me zoom in. Whoa, that's a bit too much. 0, 0, 0, 1, 1, 1, 1, 0. That's great. Awesome. So we have our rules set up. What I'll do as well is const map, like a map between the top iteration and the next one. So what we'll have is we'll have an array of 8 elements. First element is going to be, let me do this, right? So 1, 1, 1, and then next one will be 1, 1, 0. After this, it'll be 1, 0, 1. It'll be better with commas. This is probably not the best way to do it. I have no clue. I don't know. I just want to get it working for right now, and afterwards we can always refactor it, make it better, more efficient, just overall better. Okay, so this, and then afterwards it's 0, 1, 0, and after that it's 0, 0. I believe I don't have 0, 0, 1 yet. Okay, anyway, and then after this it's 0, 0, 0. All right, so we have our 8 maps, right? And our 8 rules, right? I might want to move this into new lines. Okay. Yeah, that's good. Okay, that's great. Okay, so now we have also our cells. And what I'll do is I'll remove this. I'll put the background in here. The background possibly, let's make it white for now, and we can always change it to something else if we want. Okay, as of now it makes sense, right? So we'll have an int for the generation. It'll be equal to 0 to begin with, right? And we'll have a function called generate. All right, generate will be generating the next generation, right? So eventually it'll do cells equal, we can call it next, or we could call it, yeah, I think next is fine. We will also use generation plus plus, right? Generation plus plus, okay. So what we will want to do here is for let I is equal to 0, I is less than cells, not length, I plus plus. Now we need to get the left neighbor. And what I'll do is if I is 0, then left will be 0. So if I is equal to 0, then that would mean that we get 0, right? It's like if there was an empty cell, a cell with 0 to the left of it. Otherwise, it'll be, oh yeah, and I'm missing equal sign. So otherwise, it should be the cells at index I minus 1. Okay, great. And now we need the right, which will be the same thing, but this time it'll be I, whenever I is equal to cells, whoa, not this, cells.length plus 1, then in that case it's 0, otherwise it's I plus 1 for the right one, and we'll do const middle or center, whatever you want to call it, which is just going to be cells index I believe. I mean, we will see if that's right. Okay, great. I think it's pretty straightforward now. What I'll do as well is I'm going to draw here a rectangle at a rectangle, I said. A rectangle at, let me think, at I times the scale. For the x, the y, it's going to be generation times scale, and then we'll have scale, scale. And what I'll do is I'll do fill. We will need to create const next equals an array that has a length of which would be the same as the cell's length. Okay, great. What we'll do is we'll say next index I equals, and then we'll need to figure out, we'll need to basically find the index of map. So map.find index where A, B, and C is where A is equal to left, and why is there an error here? Oh, well, sure, that makes sense. A is equal to left. Is there still an error? Expected comma. Oh, I mean, sure, that makes sense. It's normal. I just messed it up. Okay, so A is equal to left, and B is equal to middle, and C is equal to right. Okay, great. I think that makes sense. Okay, and then I have the index, but I don't want to set next index I to the index. I want to set it to equal to the rules at that index that we found, right? And then we need to fill based on that next value, right? So, and possibly I want to move this to here. And then over here, we can do fill if next index I is equal to 1, then we'll do 255, otherwise we'll do black. Okay, and currently the background is white. Oh no, well, in this example, the 1 is black and otherwise it's just white, so we'll do it the same way. I'll also be using frame rate, maybe frame rate 3, and we'll do draw. I know I had it earlier, but or you know what? I'm going to say function mouse pressed. Every time I press the mouse, I call generate. Okay, let me see now. Let's see. If I click the canvas, okay, oh, there's an issue. Assignment to constant variable. That makes sense. No, not this. Let here. Okay, let's see. I click again. I click again. Yes, we got it. There you go. Though I don't think at that position it's supposed to do this, right? Maybe, but I don't think so. Let me refresh. Up to here, it's all good. Now this is where it's giving us the issue. So whenever there's one with nothing on the side, it's supposed to be one with nothing on the side. There's supposed to be one right under it, right? So right over here, there's supposed to be a 1. So why is there not? That's a good question. I'm not exactly sure. I think we're close to it. Let me move also my, or maybe just let me reduce this size just so that you can see as well properly, right? Let me refresh. Right, so there seems to be an issue over here. What exactly? I'm not 100% sure on this. Possibly something random. Let me close this. What? What the heck is going on now? There is an issue. Let me floor this value. Okay, now it's getting further. Okay. There is most definitely an issue. What issue? I'm uncertain of what it could be. Maybe it's this, right? Where it doesn't find it. Next index I should equal to rules. Rules should be of length 8. Yeah, I'm a bit confused, I won't lie. I am really unsure as to why it's doing this. I mean, it's only doing this at a certain point, right? If I zoom out even more, it's working like a lot further up until some f-top point, right? I'm not sure why is that the case. Maybe that's normal, maybe that's supposed to happen, but I don't believe so, right? If I zoom back in, there you go. So it makes sense up to here, but then, well, I mean, doesn't make sense anymore, right? Yeah, because so you see this one over here, there's supposed to be 3 under it, 3 black, because if we take a look at this 30 example, we see where is it? When there's 1 in the middle, there's 1 under, And since there's 2 on the left like this, there's supposed to be 1 to the right of it, and this one there's supposed to be 1 to the left of it as well. But right now we're not getting that, which is really frustrating. But why is that? I'm not. Oh, here, there we go. Right should be -1. Maybe that's the problem. Yes, that was the issue. Okay, great. So we're pretty much done with the sketch. Hopefully you liked it. I believe if I were to do 26, it should give me a pretty interesting one. Yeah, so this is the Sierpinski's triangle, which we have looked at previously. But yeah, hopefully you liked the sketch. You can make it go visually up, right? As you create iteration, it just goes up. Maybe if we were to do the scale, so let me add back. Let me do function draw, and let me put in here just generate, right? So that's cool. We could do a scale a little bit smaller, maybe like 5 instead of 30. Right, so it's going to take a little time. Let me move my face as well. Wait. There we go. Okay, so let me move my face over here, just for you to be able to see it. Right, so this is making the Sierpinski's triangle. Pretty slowly, I'd have to say, but if we wanted, we could always just set the frame rate to maybe 15. It should be a lot faster. There you go. So, and we could also do no stroke, just because it's difficult to see it properly. Otherwise, no stroke. See this? Okay, there you go. Right, so this is creating the Sierpinski's triangle, which we've looked at in prior videos. I mean, what else? There's so much more that you can do with this. You can add colors, right? So you could have like an array of 8 colors or something, right? So let me pick, let me go my favorite site, colors, this one, and let me look at, not palette generator, I want explore palettes. And let's take one that is at least 8 long. So, and one with multiple, this one's fine. All right, so let me export this, export palette, and let me, I believe embedded should be fine. Yeah, that's great. It's really small for my eyes, but there we go. Okay, let me copy this. Let me put it here, const colors or palette. I don't even know the order, but it doesn't matter, because what we'll do is we'll use here, instead of this, we can just say, we can just cut this out, call it index, and const create the index variable over here. It's great. Let me put this on the same line. I mean, we already know what it does, so it's fine. And here, instead of fill whatever it is, we'll do fill, and we will fill based on colors at index. Let's see this now. So let's see. There is an issue. Let's take a look. Is there actually? Why is it not showing anything? I'm a bit perplexed. Colors? Oh, there you go. I need the pound signs, otherwise it's not interpreted properly. Well, let me just add this. I don't think I need more than those, but okay, there you go. Now, there we go. So now we can see our Sierpinski's triangle in color. We can go back to the rule 30, maybe put this a little bit bigger, maybe 10, right? So you can see it a little bit better now. So it looks good. We can move it up by 1 as well, which would be minus scale, right? Minus scale, there we go. So it starts at the top. We can go back to the rule 30. Save, let's see. All right, so this is our rule 30 with colors. Let me remove this, let me refresh. There we go. Let me do as well generation. Right, so if I were to resize it now, okay, it starts back at the top, right? So yeah, so that's pretty much it for this sketch. Hopefully you liked the sketch, and you can add on to this. Like I said, you can make it move up. You can make it do a lot of stuff, right? We can try a couple more rule that look interesting. Well, this one, rule 62, looks pretty cool. 62, I said, right? So let's see. Yeah, you see, like one side is totally like special, and the other one is also special, but it's cool. They're special in their own ways. What else, right? Well, there is a lot of Serpinski Strangle. Probably we would get different colors with those. Different one, right? So we tried 26. Let's try 22. And then afterwards, let's try 18, right? So 22. See it? Okay, cool. 18 now. Oh, those are different colors, right? And if we compare with 26, those are similar to the 18 one, right? Let's see. Rule 45 looks interesting. 45. 45. Oh, that's rad. That's really cool. I like this one. 45, really cool, real nice. Yeah, I guess 45 would be somewhere in there. It would be like 0, 0, 0, and 1, 1, 1. Pretty cool, pretty cool. 57 looks also interesting. 57. 57, let's try it out. Yeah, pretty interesting. Oh, that's nice when they merge. Really cool. Yeah, so I would really suggest for you to try it out. I mean, it's really not a long piece of code, right? If we were to remove what is not needed, we have about 60 line of code, right? It's pretty cool that it's able to do this with only 60 line of code, right? It's basically just, oh no, I don't want to save this. I want to save this. Well, I broke it. Let me see, what did I broke? No clue. Let's take a look. Unexpected token. At what line? Line 1. Yep. There you go. All right. So about 60-ish lines of code, which is pretty cool. For what it gives us in terms of results, looks amazing for 60 lines of code. Play around, change the palette, maybe the color palette, right? I took mine just off the chart right there, but hopefully you can like do it yourself, create one yourself, make something more interesting, maybe embed this principle to a different sketch that you've done previously, just to create maybe a pattern or anything really. Hopefully you liked it, enjoyed it, and followed along with it. It wasn't too bad, I believe. We did it from scratch. I believe I did it once previously, but like a couple of years ago, but it's really not complicated. I'll have this one, this link, this page linked down in the description down below. And yeah, that's it. See you in the next one. Thanks for watching.